Right. Guide block. Guide block. Obliques then. Some strange isometrics, maybe I call them. I don't know, oblique drawings. I definitely don't draw like these ones very often, but I think it's worth covering just a couple drawings so we get that perspective. So guide block, next one. Like I say, you're gonna have to do the whole ISO stuff. I'm just gonna jump to, I mean, we want a full completed drawing here with all fully dimensioned as well. So I'm just gonna jump in and just do this portion of it. So it is in inches, so it's an inch template. So I'll use the inch ISU template, and I'll use this PDF to draw me. So or to draw with. You can see that this is the kind of that like isometric pictorial that's on 30-degree planes here, like we just drew on our base map. We're gonna actually change that up and do it this way though. So let's do that. And I'll probably fumble this a little bit because I don't draw that way as this way as much. So let's see. It's probably since last year I haven't drawn an oblique style. So let's see if I can fumble this. It's the guide block, right? What's the next one? Yes, guide block. So I'll pull up my PDF for that I have attached. ISO PDF. So I got this up on my other screen, but I'm gonna kind of build similar. So, and I'll go to the assignment here. I think it tells us the scale is going to be half scale. So this is a cabinet oblique. So really, if I just read the description of what's going on in a cabinet oblique from your textbook, 511, it's actually 5, maybe 10, 509 maybe is the cabinet oblique. Cabinet oblique drawing is also drawn with a receding angle of 45 degrees. The scale along the receding axis is half size. Objects have a greater depth than width can be drawn in this form. So if they have a greater depth than width, this is a good candidate for this type of drawing. Cabinet makers often draw their cabinet designs using this type of oblique drawing. And then there's an example of one in your book. It's been drawn. I like in your book on 511, it shows like kind of the 3 different obliques, which are if I talk about the differences, the cabinet oblique is the middle one that we discussed. The first one they say is the cavalier oblique. It also uses a 45-degree projection angle, and they draw it at full scale though too. So the 2 images they show the same image, one drawn at full scale, one drawn at half. You can see that difference. And then general oblique is the third kind, but it's kind of like a cavalier oblique. It's just a general oblique. It can kind of be whatever you want in a way. The general oblique drawing is only drawn at an angle other than 45 degrees. So it can be like 30s, 60s, 90s for a general oblique. And they can really be drawn any scale from half to full size. The one that they show in your book is they've drawn like a general oblique at a 15-degree angle. So it's kind of an oddball one. And then it's at a 3/4 scale depth. So it's just like a general oblique is just kind of, I guess it just depends on the particular part and what projection angle I might establish. And then maybe if I'm going to do full scale depth or if I'm going to do half or 3/4, I guess. So to me, it's kind of like a cavalier oblique, only cavaliers are definitely generally a full scale, but even on a general oblique, I can draw it at full scale. So then it becomes a, other than it's not at a 45-degree angle. So I guess the only difference with the general is it's an oblique that's not on a 45-degree. I mean, but it still is with the front view determined, and even in the isometric view of it, the front view is actually still parallel or perpendicular to the line of sight. So it does have that characteristic, definitely different than how we just drew that base mount on all 3 of these obliques. So, all right, let's do this. I just wanted to point out that difference there. And more for my sake, Texas actually, because I just kind of forget, like, what are the particulars? Why? Oh yeah, that's one. So cabinet oblique at half scale is what I'm going to draw. I'm going to open up my inch template then to get started here. New inch template. With just the ISU start here. Well, I'm just going to open up my one that has just a B size sheet only, so that's all I need. And let's start this thing. So I'm going to start mine anywhere in here. I know that you can build your orthographic anywhere. So I'll just build mine out here somewhere for this particular oblique. But I think I'll still build like a glass box. I think I'll put this object in a glass box here. So if I just look at this real quick. So what I'm going to do is I'm going to put this front surface. So, you know, the way this is drawn already is kind of leaning me towards this is front, right side, and then top view surfaces. So I'm going to put the front view surface almost as if I was going to draw a front view, and then I'm going to leave that and draw my perspective view here. But so I think I'm just going to build my kind of like I'm going to build like what I would for a front view glass box, and I'll project from it. So if I looked at what my front view overall size would just be 1.25 inches, I say, by 3 inches. So if I'm just going to put in a glass box, it's 1.25 inches by 3 inches, totally just perpendicular to my line of sight here. So I'm going to come in here with a rectangle on my construction layer that is, zoom in here a little bit, that is, did I say 3 inches? Everything's like 3 inches by, okay, 1.25 inches by 3 inches. 3 inches by 1.25 inches. So that's kind of what my front view would normally fit in this plane. Now I'm just going to project off at 45 degrees. So I'm going to kind of break away from and so I feel like when I draw this type of a perspective, I don't really need the ISO planes turned on, because I'm really not I'm not at a 30-degree angle or a 60 or anything that's going to be parallel or perpendicular to this grid plane. I'm actually going to be at a 45-degree angle projected back. And so I'm going to do that with my 45 tracking on here. I've got that tracking. So let's do this. So at 45 is going to be my perspective away from me like this, right? So, and then we're going to do it at half scale, which means I'm not going to be, let's see what our part width is, or our part depth is 1 3/4. So that would be at full scale, which they say is not a great candidate for this kind of perspective, although that is what the Cavalier oblique is. It would be at full scale. And it's fine as long as your part isn't overly long, right? Like you can do a draw at full scale. Oh, sorry, overly deep. If you have an overly deep part, full scale is I think it's very poor looking perspective, maybe. So this is what kind of prevents that, is to do a half scale, that issue. Even though our part is pretty dang small, probably I could draw this at full scale and be probably fine and fall under the Cavalier oblique. But let's just stick with this, and we'll do half of 1 3/4 is my overall depth that I'm going to draw. So I'm going to just do a quick little. Yeah, it's 1.75. I'm going to do half of that. Yeah, so just 0.875. So it's only going to be 7/8. Yeah, 7/8 deep here off this 45-degree angle here. So 0.875, exactly right. And then I should be able to come up and do the same kind of like projecting here potentially, but maybe not because the projected. So I might have to do a little bit of like like go long here, then come back here, and at 45-degree angle. See, I didn't even like quite cross them actually, but that's going to be where I want these. So I might use extend here. You just might not be able to get that snap tracking to help you like line up point to point as much. That's kind of like two sides of my glass box, right? And then this thing's going to come back at a 45-degree angle too. So you just kind of draw this long if you need to, and then draw this one straight across. You know, I would argue it's not that this isn't the best object to do that. It's just an exercise of this, because I feel like it doesn't give you a lot of great isometric details. Even if I just look at the assignment and can recognize that this is maybe a better perspective than this one here, right? But I get the gist of it here. This is the direction we're headed now. So trim this out. But it still can help you to put in the glass box. It's going to be, so how deep it is. I know this can look confusing though too, but I want to know maybe where the back. This is would be the left side surface plane, right, and right side surface plane, and then these two lines should be horizontal from each other and line up end to end. So at least I still this one looks like a cube of butter to me. This little cube here, but There, so I still have my full glass box. It still should all fit in within here, right? Like this is the boundary of where my part has to fit. So, and I think I generally start these with the front view, and at least the part of the front view that's right perpendicular to my eyeballs, right? So it's not all of it. There is a mitered section of the, there is an angled section of the front view here. It's going to be foreshortened in the front view, but I'm going to put this in actual size right here. So this is going to be full size. So I'm going to draw this first. I'm going to kind of build off from it and piece together what I can, knowing that any depth dimension is going to be essentially half of what it actually is. So any depth dimension is reduced by half. Okay. But so I have that up on my other screen just so I can trace my part here. Yeah, so front view would still look like this. At least the front view that's all the way up this way, and it looks like it goes over 1.25 inches this way, 1.25. Your full size measurements. It's going to slope down from there and hit that other miter, so it gets a little complicated to piece this angle together. I'm not really getting it. So I do come over this way 2 inches though, right? Then I'm going to come up some unknown distance here. That's going to be, so maybe I'm going to have to piece this together with whatever the other information I have. I'm not explicitly given those dimensions, so I'll just piece that only that much together, really. Just that start. And let's see if I can figure out maybe the right side view here. No really right or wrong way to start this. You can stop with, I feel like for me, got a little bit of the front view in, maybe I'm going to work on some of the right side view at half depth, but normal height. So really, this little chunk would be up a half inch, and then it's going to come back at me at a 45. Doesn't come clear over to here, but maybe I'm going to draw it over here for a minute just to hold the place. It actually comes up here. 1.25 is as far as it comes to me, but it's going to be half of that. So you gotta have your calculator up. Maybe use that. Yeah, this calculator I might need. 1.25 is what this would measure over. So I'll just do that by half. Divide that by 625, exactly right. So that's technically how long that line should have been. I could do that here and then trim that other one. So 0.625. That's how big this little right side surface would be. And I get rid of this. I just drew it extra long. That's really what the true right side surface is, only this little bit of the surface. So from there, I feel like across the bottom, I can hook up these 2 points now, right? This is going to be there to there. It's going to go there to hold that off on how that's going to all jog together from there up to here. This is going to be sloped down. I might piece that together. I can't remember if this is tricky. That looks tricky. Maybe not too bad. I feel like now what I'm going to do is kind of start working on the backside surface and some of the top and try to start defining more of the right side, and maybe I'm still trying to piece in the full right side view, which is going to be all this slope section, and tie that into the slope section of the front view. I've got at least one, but I got to have some more information. So I know that this is going to be, this was what, 1.25 there. It's also going to be 1.25 this way. And then that one is going to slope down to here, right? Yeah. I'm kind of getting the feel for what this, for sure, even if I lock these together here, that's kind of that top surface. I know it's going to have a bunch of notches in it, whatever, but this kind of starts to help me see the plane that this surface is on. I don't have this side dialed in yet, but eventually this is going to come up in here somewhere, and this is going to come down. I don't know if I'm just going to go from here. I'll work this out piece by piece. Yeah, I think it's complicated here too, where these come down and slide into here. Maybe I'll start to kind of work on the top here, how it kind of fits, and then slide it into this and see if I can terminate it. Yeah, I think so. So these are half-inch typical from here, from this corner in to this corner in. So that means they're just a quarter inch, 0.25. To me on both of these. Comes in a quarter, and then it's going to turn down. And those heights are actual length, so it's not it's just the depth that's been diminished in the length. This one's going to come down 0.25. I think all of the jogs in this are like quarter inch. 0.25 down, 0.25 over, 0.25 down, 0.25 over. So the line comes to there. That's that first top surface, 1.25 inch by half size of only a quarter inch there. And it came down. Some of this is going to probably be buried. I don't know what for sure. You know, I think I'm going to draw this one over too. This one comes over to that. So that's that surface, that top surface. I decide like where that point is going to need that point. Might just be that point connect to there, yeah. Okay. Yeah. Well, I can still see it. It would come through here though further, right? Until it terminates somewhere in this front surface. I don't remember drawing this. Probably should have practiced this one time. But I knew I'd probably fumble a little bit.
Are you just trying to,
I don't know.
did you just bring down, I don't know, I would just make a copy of that top slanted line and do its basis point on the top left corner, and then drag it down to the next point that you want it on.
Right here. Or
yeah, or just any of those points that have that same angle on it.
yeah, I got you. I got what you mean. You could just like you could use this as kind of moving it across this plane, right?
Yeah,
To where, and then it would show you where to terminate this here.
Next point.
Yeah. And maybe I can even draw that with construction or not. I think that would be I just change mine to construction, and then maybe I'll make a copy of this. Like you're saying, if you move this from this point along this plane, that's kind of where that would terminate, right? And then you come over to the next one and find out where it terminates. And yeah, so like right here, you project. That's where that would terminate. There. Yeah, that's a good, just slide along that plane. Draw those kind of long and through. You won't see all of them, huh? They'll kind of get eaten up by that view. So let's see, this would look like from here down, be a visible line. I'm gonna probably trace over this again with visible line work, but so that one comes across, and then we really would trim that out. It kind of looks like that surface now. If I think about the next one, where it hits there, it's gonna come back this way. Yeah. 1/8 of an inch is all, maybe? kind of confusing how that's this surface. But you wouldn't see much of that, so I'm trim that.
We're not doing hidden lines again, right?
No hidden lines, yep, just trim them, trim off what would be hidden. Exactly. So that would look like that, and then it's gonna come back to, definitely come back this way until it pretty much gets buried in the next, so maybe I'll just pull this through so it doesn't look like I'm finished that. It's definitely this surface, then it comes into this surface, which I just barely get a little shadow of it there. Then this one picks up and kind of overrides anything else, but I would see something like that would be that surface. And then from there it goes down another 1/4 inch right here, right? 0.25. That's as deep as it goes there. But we need to know how far this comes out from there, right? So this I can just take out a little bit long that way. I kind of, and I might keep track of it this way, even though it's gonna all be buried. I'll just kind of do that. If I make another copy of this thing here, slide it along this axis until
They're only 0.125 for you.
this way.
No, in, right? Yeah.
Yeah, this way. It's only 0.125. Yep, and these are 1/4 inch down. Yep, yeah. I think what I need to do is kind of copy this to be on the same plane, but I kind of want to know from here, right? That's where one should. So that looks kind of weird, but I'm looking to extend this to there, right? That's where it kind of meets all that same surface. Just extra overdrawn, but. I drew this line down, but I'm probably gonna, I don't need that. That was just for me to mostly track like where this came. This could probably be construction work for me. This particular line is not, that surface is not, it just, it's like, come down from here to there. So it's there. Down, and then it's gonna come back over 1/8 of an inch from there. So I feel like this is gonna kind of end here, come back 125. Looks something like that, and then it would also come back this way and get eaten up by other view. It's kind of choppy, huh? That's that surface there, yes. And going to copy that again. This surface over to here. This is where that would slope down until it starts hitting stuff. At this point, I've got to go back up, come across. So there's only going to be a little bit of showing, right? I think I have a little bit. If you get lost here, you can come and look at this thing a little bit. Maybe get an idea what I'm showing here. Come back here, and this one's going to come up from there. So probably I just need to draw my other one. I brought this one down, but I got to kind of figure out this little jog here. So I brought this one down right now long. I'll bring this one up long, and then I just need to like project this one through to kind of know where this little jog terminates like that. Yeah, that looks pretty. Yeah, building this section, and it's kind of like a little dog leg in this thing here. We'll figure this out here. I'll just piece this together still. Now, I don't know how many lines are coming across here. It's hard to see that. really the only thing that will be showing here is that line there and then this line here. So it's just kind of a two, that's why it looks weird here. It looks a little bit blurry. Just two lines that are pretty close to each other there. And really my back's kind of done because where I terminate against that is about done. I just need to make sure, yeah, it's good. I'll focus on this here. Which I think is just a copy again. This. Just gonna slide up. I'll undo it. Yeah, it does help to do that. Something just to keep yourself on that plane with this projection. It's almost like a projection plane that you have here. So this one then comes up until it hits this one coming across. So I know I'm making it. It gets to be a messy grid that gets confusing. It's not a normal like. This is going to come across. I don't know out here somewhere. What that does is allow me to trace over this. So I kind of piece together to try to make sense out of what I got going on here. And then it comes over here, and then it comes back up to here.
How far to go from the T, like, so the start of that T, the corner, the top, left corner of the T, yep, right, yeah, right there. That from there to the diagonal down. How far down did you go?
Let's see here. So
From there?
this is a 1/4 inch. That's the normal height.
Oh, I meant the other, so the diagonal is the right,
This-
45 degree in the right, from the corner that you were in.
This corner.
No, so the 45 or however many degrees that is to the right, yeah, I have that construction map, but how far down did you go with that?
To here.
Yes.
Yeah, I didn't know. There's no, I just wait until this one comes across until they intersect. So I had to have this one, because this is how far down that surface is, 1/4 inch.
Oh,
And then once I hit that point, I projected this line across. And then where those two intersect is it. So this one, yep. I used this, and I copied that over. So if it came over, and then I copied this line to that point. So I had this surface look. And then, so I had that long line, and then I came straight down perpendicular, 1/4 inch, and then I projected that to where those two cross, and that determined this length, essentially. So it wasn't by length, it was kind of by, intersecting grid there. Yeah, that's tricky though, yeah. And then I came back this way, 1/8 of an inch, right? And created this intersection point too. So I made another copy of this to that point. So I had this long intersecting construction line here. And then I had to add myself another construction line here. So on that 45-degree projection plane there, I did extend this line as construction work so that I could create this kind of intersection point here now with what comes up from there, where it crosses there is kind of where this terminates. And then I had already made this. I'd already copied this line from here and placed it over here. So I had this long construction line. But when I turned back this way, 1/8 of an inch, that crossed this. I was able to do that little job there. What I've got is I've got a bunch of like visible line work that I need to trim out now. And maybe I can turn off my grid and just take a good look at this. When in doubt, turn this off and be like, oh, I have a lot of missing stuff. Yeah. Like this one I made into a construction line is Y, and that's what I would just copy. And so I'll redraw it. Yeah. And then all of this is going to get trimmed. It's just going to be buried behind that surface, so I can't really see it. So I'll trim that out. This one doesn't really exist, and that one doesn't really exist. Either does this or this. Yeah, so it's kind of getting there. Oh, I can see one I need to come across. So sometimes even without a construction grid, once I turn this off, I can say, oh, this one's got to follow parallel until it disappears like that. Then I've got surface, 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 then surface down, and then across a little bit. Then back up, I can't see that very well, but I can see where it turns back this way. Then I can't see that surface either, and then back to the top. So the last thing for me to piece in is just how these two work together here. Which should just be like making the copy of that construction line back over to here, and then turning, extending that up, and then maybe it's a dog leg here, right? Like, let me see. Back on. So really, from this point, it should look like Copy this one more time. Sure, we'll just copy that to here. That's going to be visible line work, and then I'm going to extend this one where it hits there. And then what it really does is that from that point, it has a little dog leg that comes, this is where it comes back. So it looks like it's not a straight line, for sure. And then we can trim this out, right? Trim.
Wait, how did, what?
I know, huh? Yeah, what I did is I kept with this surface, this surface concept idea here. Is I made a copy of this and I brought it over here and placed it on this point, and that was going this way. This line you maybe have not drawn yet, but I had drawn it. I just hadn't drawn an arbitrary length. I just pulled it up. I didn't know exactly where it would terminate. Well, where it actually terminates is when I bring one of these over to here. It hits there, and then from where it hits, it goes back to that other corner. So it makes this line into what I call the dog leg. Just gotta jog to it from this perspective anyway. If I was truly at my front view, it would look like it would be a straight line because that plane, this surface is all in the same plane. Because I'm slightly skewed once I project away like that. Yeah, it is a weird. That's why I say I don't draw like this very often. Kind of squishy, right? It kind of is like. But I do know that if I wish we could draw something really deep, and I think this perspective would be helpful for that. If it was deeper than it was wide, like a cabinet is. Sure, think of a cabinet. And now, if you look at your cabinet drawing, probably if I pull up a cabinet drawing to show cabinets like in a kitchen. That's it, though. This one's done. Of course, you gotta do all your other. So it's not done, but the isometric part is done. The cabinet oblique at half scale.
Exactly.
What's that?
I just drew all the other ones and I just feeling curious deja vu.
Like you've done it before.
I'm pretty sure it's done.
Yeah, I kind of looked for it, and I thought the same thing because I kind of looked for that drawing. We did one. Oh yeah,
Very thin.
very similar. Yeah, you did one that is very similar, but it is different. It has some holes in it, but it's got this going on for sure. Yeah, there was like a hole in it here and a hole in it here that went through, but it had this kind of a front feature shape, and it was. Yeah. I know the one you're thinking of because I actually dug through my list and I was like, I think I've drawn this too, and we actually have, surprisingly. And then it needs like when you'll notice that this will be a foreshortened surface in any of your views. Your top view will show it top down, so it needs an auxiliary view. And so that's why on my assignment that I did pull an auxiliary view and kind of rotated it like we did that other. So I actually pulled that view out, created a viewing plane, pulled that view, titled it. Once you pull that view, it's going to be at this angle, and I just like tipped it down so that it was, and then I can dimension this essentially. It makes it so that the only thing that I wasn't really able to dimension is maybe just this length or this, which might be more of a width actually, just because it's foreshortened here, so I can't dimension that here. I could dimension it here, but it would be an angled dimension, and we kind of avoid angled dimensions. Even though you may work in an industry where angle dimensions are totally fine, I'm just saying like ASME, we kind of avoid them. But the only reason why you need that is because maybe it's just a better detail on this rather than just pulling in a line dimension here. That is its true length, this that you're in dimension here. And you really don't need the heights because this is a true height. Maybe so. I don't know. It's just one more exercise, one more thing to add there. Since we know it would be a foreshortened. It's foreshortened there. It's foreshortened there. It's only top down there. So technically, I could make an argument that then I should detail this view, right? To like this surface. Well, yeah. Then we just start to say, yeah, I probably should. This is foreshortened. This is foreshortened. Why don't I pull an auxiliary view of this? Yeah, it's a good argument. I could. We don't have to, but that is. It's only showing its true length here. I can dimension the details though. in here for the depths and the heights, so, yeah, done deal. Good. So that's pretty painless. Hey, I finished on time. Holy cow, that's never